Well, good evening, everyone. I'm Darren Gooding, and I'm the Eastern Washington Inspection Coordinator for the Washington Tree Farm Program. And I want to welcome you to our third and final session of our Eastside Fall Forestry Seminar series. And just to start off, I just have a few little logistic things I want to cover real quick before we get started. So just to let you know, as you saw from the little notice there, these webinars are being recorded, and we'll then post those, and they'll be available shortly after the end of the seminars and be posted on the Washington Tree Farm Program for you to view again later. During the sessions, as the presenters are talking, you can put questions into either the chat box or the Q&A function. I'll be keeping an eye on those and monitoring those, and then we'll do question and answer. We'll allow for about a 10 to 15 minute question and answer period after each presentation. And then I'll also post a survey at the end of the webinar. I'll drop the link for that into the chat box, and you'll also receive a follow-up post-session email. We'd appreciate any responses that you could provide feedback on the seminar. That way we'll use that input just to factor into what other format and topics we would do in future for next year's and future seminars. One more thing before I move into our first presenter, I was asked to do a quick little plug here as an invitation for those of us on the east side. There's going to be a Eastern Washington Fall Farm and Forestry Field Day on October 2nd at the WSU Vetter Research and Extension Forest. So I'll leave that up on the screen for just a second if you catch that for extra info for contact information. If you want some extra information, you can always, if you want some information on that or need the contact information, just put a note in the chat box for me, and I'll just I can always drop you the web address or the email contact. If you want more information about that, I can put that into the chat box for you. With that, I'm going to stop sharing and do a quick introduction here for our first presenters. So our first presenters for this evening are Dr. Jessica Holofsky and Dr. Dave Peterson, who will discuss how current changes in our climate will influence current and future disturbance regimes, and discuss how small forest landowners and tree farmers can facilitate climate resilient forests. And I'll give quick little bios for both here. Both of them have such great long history. I won't take time to read all of it to you, but so Dr. Jessica Holofsky is currently a research ecologist with the Pacific Northwest Research Station. She's currently the director of the Western Wildland Environmental Threat Assessment Center and the Northwest Climate Hub, as well as a research scientist at the University of Washington. Dr. Dave Peterson is a professor of forest biology at the University of Washington School of Environmental and Forest Sciences, and is an emeritus senior research scientist with the U.S. Forest Service Pacific Research Station. So at this point, I will go ahead and turn it over to both Dr. Holofsky and Dr. Peterson.
Great, thank you very much, Darren. Very happy to be here this evening. I'll share my screen here, make sure everybody can see that. Look okay, Darren?
Yep, can see it.
Okay, great. So I'm going to start off the presentation tonight, and then Dave will take over. But as Darren said, we're going to be talking about how climate change will affect forests and disturbance regimes, and some potential adaptation options to try to increase resilience of forests in the face of climate change. So to start, I wanted to show some global temperature trends since 1880 here, and these are, you can see changes from the average global temperature over time. And you can see the last 10 years or so are right up there. In fact, the 10 hottest years on record globally, 10 of them have been within the last 10 to 15 years. So this trend is pretty striking, that we're seeing increases in temperature across the globe. And this is what we're looking at in terms of projections for the future. So on the left-hand side here, we have the black line is modeled historical, observed, and then the gray is modeled historical. And then we have projections into the future using global climate models. And there are a couple of different scenarios that are used for these global climate models in terms of the concentration of greenhouse gases in the future. And these are called representative concentration pathways, or RCPs. So we have RCP 4.5, which says, you can see here, global cooperation. It's likely that we're going to substantially reduce greenhouse gas emissions and limit the temperature increases. RCP 8.5 is kind of a business as usual scenario, because we're not going to do a lot about greenhouse gas mitigation. And as you can see, the temperature ranges are higher for that one. You can see they do track pretty closely until about 2050, and that's when we really see the divergence in where those greenhouse gas emissions really make a difference in terms of what we see for temperature changes in the future. You can see the RCP 8.5 is in the range from 8 to 14 degrees Fahrenheit increase in average annual temperature in the Pacific Northwest. So we've already seen quite a few changes in temperature and our climate here in the Pacific Northwest. That's been reflected in a couple of different ways. And one is the USDA plant hardiness zones. So we have the 1990 map there at the top, and then the 2012 map there at the bottom. And you can see there are changes, that there are actually shifts in those hardiness zones. We've seen sufficient changes in climate that it's affecting what we can plant in our region and where. And this is another look at that for Washington. And it's interesting to note these really, the hardiness zones are based on minimum temperatures, and especially extreme minimum temperatures because of frost. And we've seen over time that those minimum temperatures, and especially those extreme cold temperatures, have increased faster than the high temperatures, both here in Washington and really in most places across the country. I also wanted to start with a little bit of context. When we're thinking about how climate change are affecting our forests, it's important to know where we've been and where we are now. Almost 90% of our forests and lower elevations have been logged at least once, sometimes twice. We've had a lot of land use change that has resulted in forest fragmentation and limits the connectivity of our forests. We have non-native plant species, insects, and pathogens. And we've also been living in a pretty wet period, and we really haven't had significant droughts in our country since, in the Pacific Northwest, since the 1930s. So shifting here to how we think about how tree species, distribution and abundance will change with climate change. And we have a couple different sources of information we use to think about this. One is paleoecological data that goes hundreds to 1,000 years in the past. That's based on lake sediment cores and also tree rings. And that can help us see how climate changes of the past affected tree species in our forests. I can use vegetation modeling. There are several different types of models that tell us how species and ecosystems are going to respond to shifts in climate. And then we can use our knowledge of species life history to determine how they're going to respond to these shifts in climate. So I'll give a couple of examples, or an example of each of these. So starting with the paleoecological evidence. So again, this is looking at lake sediment cores and looking at the pollen and charcoal in them to determine what used to be there in terms of plant species and how frequent fire was. So scientists go into the middle of the lake, they use a coring device, they take this core and they look at the different layers and determine where the pollen is in those layers over time and where the charcoal is. So this is a little bit hard to read, but all the way at the bottom is going 10,000 years in the past, all the way up to present day. And we can look at some different species and how there have been changes in abundance with those species over time. So these are pine. You can see actually in the middle part of that, there was a lot more pine than there is at the top, so present day. And that was that middle spike is actually associated with the late Holocene, which was a pretty warm and dry period in the Pacific Northwest. And we can look at other species, Douglas fir there on the left in the circle part. There's actually more Douglas fir in the past, especially during that warmer and drier period, than there is now, believe it or not. We have fir, the aves, there's been pretty constant over time, but was more abundant before that warm and dry period in the early Holocene. And then we can see that hemlock and spruce, they're relatively new on the scene and more abundant now than they were in the past, and particularly in that warm, dry period. So we can expect these species that did well in these hot and dry periods in the past to do well in the future with climate change. And then red alder, which also is more abundant now than it was in the past. We can also look at vegetation modeling. So this is some modeling for the Eastern Washington Cascades that the Washington Department of Natural Resources did. It's looking at the current climate there on the left, and then the mid-century there on the right. And it's using information on future temperature and projections for how water deficit or water stress is going to change in the future. And you can see with climate change on the right there are some shifts with more water stress. We see the expansion of the dry ponderosa pine and shrub ecosystems. We see dry mixed conifer kind of shrinking a little bit, but moving into areas that are currently moist mixed conifer. And we see the moist mixed conifer moving up into the cold forest locations. And overall, we see a contraction of the cold forests. So we see in general expansion of those drier types, and that these vegetation types are kind of moving up in elevation with climate changes. And then we can look at the characteristics of different species. And we know that species that are likely to do well in the future are going to be able to disperse a lot of seed, disperse it relatively long distances. They're going to be able to withstand high temperatures and low soil moisture. They're going to have to be tolerant of more disturbance like wildfire. In general, be competitive species and have high genetic diversity. So how these trees grow in a warmer climate. So we can break this up into different groups, and starting with the Eastside conifer forests. We know these forests are currently moisture limited, and that will continue to be the case in the future, and in fact, even more so. So if they become increasingly moisture limited, growth is likely to decrease for our dry conifer species like ponderosa pine, larch, and Douglas fir. And the same is the case for our low elevation west side forests. These forests are also moisture limited by the long dry summers. And so in general, climate change, we're expecting growth decreases for the west side conifers as well. It's not the case for the high elevation forests, because these forests are currently energy limited. They're limited by snowpack in the relatively short growing season. With decreases in snowpack and longer growing season, the growth is likely to increase for species like subalpine fir, mountain hemlock, and lodgepole pine. And we may see expansion of forests at higher elevations. Riparian areas, wetlands, and groundwater dependent ecosystems are also going to be affected by climate change. You know, there are going to be decreases in snowpack, changes in water availability. It's likely that stream flow will be higher in the winter, but then when all the water runs off from the snowpack earlier in the year, those flows are going to be lower. And that can really limit riparian vegetation. We may see some contraction of riparian areas in some places where we have streams at lower levels than they used to be. That could also happen in some wetlands. And groundwater dependent ecosystems may be a little more resilient if they're sources of water or groundwater. But overall, we could see changes in the susceptibility of these systems to fire and shifts in species composition to species that aren't quite as wet loving as we currently have there. So those are some of the direct effects of climate change on species and forests, but we know that increased disturbance, those indirect effects, are going to be a major impact on ecosystems. They're really going to be the drivers of ecosystem change with climate change. And we know that climate change is going to affect insect species. We have the mountain pine beetle. This is a native species. We've always had mountain pine beetle outbreaks here, but warmer temperatures have really accelerated its reproductive rate in some locations. And the increasing temperatures, particularly the extreme cold temperatures, have allowed it to expand into areas where it wasn't previously. And this shows the mountain pine beetle outbreak since 1990. You can see there have been some substantial outbreaks in British Columbia, in Eastern Cascades of Oregon and Washington, and also in the Rocky Mountains. And these outbreaks have covered over 50 million acres. And so more locally, this is some data from the Okanagan-Wenatchee National Forest. This shows the number of trees killed. And between 2000 and 2010, there were some substantial outbreaks of the mountain pine beetle. And you can see there are over, for example, 300 million trees killed by beetle in 2009. And we expect that there will be outbreaks like this in the future when trees are stressed by drought, high temperatures. They're more susceptible to insect outbreaks like this. All right, and now shifting to fire. These are some recent wildfire statistics. You can see across the Western US, we've had several years with over 10 million acres burned. And in Washington, we've had a couple big years, 2015 being one of the largest in recent history with over 1 million acres burned. And if you remember, 2015 was the year without snow. We had near normal precipitation in the winter, but it was quite warm. And so a lot of that fell as rain rather than snow. And then we had a pretty dry spring into the summer, and it just set us up for some extensive wildfires, over 1,500 fires in the state that year. And it had an immense cost in terms of suppression and then losses, particularly in our rural communities. And this was a look at the drought monitor in Washington at the end of August of that year in 2015. And you can see that most of the state was in that D3 or D4 colors, which is extreme to exceptional drought. And again, when we have very dry conditions across the landscape, whenever we have a fire start, that it's able to burn and initiate fire. So what are we looking at for the future in terms of area burn? So there are a lot of different types of models we can use to look at that. Some are based on statistical relationships, some are based on more processes. This is from a statistical model, but overall we see that for about a 2 degree Fahrenheit increase in temperature, we expect the annual area burn to increase by about 2 to 3 times in the future. And we have to remember that these extreme years, that's kind of on average, but the extremes do matter. We know that our agencies are very good at fighting fires. They control most of them in a very short period of time, but we have to think about what happens under those extreme conditions. And 2% of the fires that burn under extreme conditions are burning over 95% of the area and resulting in really high suppression costs. So it's not necessarily a fire control problem, but a problem of increasing incidence of extreme burning conditions where we get really large and uncontrollable fires that are causing a lot of the issues for us. And another way is to think about it is looking at fire risk, or when we have those really extreme weather and fuel moisture conditions, and we have a high to very high fire danger. And these are the conditions we expect to occur more frequently with climate change, with higher temperatures. And so under those conditions, fires can start very easily, they can spread rapidly, they can exhibit extreme fire behavior, and they can be very difficult to control. And so this is what we're expecting to occur more in the future. And this is a projection for those very high fire danger days. This looks at about mid-century, and you can see a lot of the east side is in the kind of darker orange to red, and the red range is about 30 days of very high fire danger. When we get any ignition, we can expect there to be a start and a fire event. And we're starting to see, with more and more fires occurring and also these insect and disease outbreaks, we're starting to see some interactions. And let's see if I can get this to start. There we go. This is starting back in 1997 and going forward. You can see the different footprints of fires and insects and disease. And especially as we get into the late 2000s, you can see that some of them are starting to overlap. And in some cases, we're getting reburn events or fires burning over insects and disease outbreaks and vice versa. And so there could be some surprises here where we have these interactions between these different stresses that are really going to affect our forests and their trajectories for the future. So a little summary here on what we're expecting in terms of vegetation change and disturbance. So with more drought limitations, we're expecting lower growth for most species in most locations. Those high elevation locations are an exception. We may have some mortality events from insects and in some cases pathogens, depending on how they respond to the specific climate changes we experience. We can expect larger fires, increased area burned, some potential disturbance interactions between fire, insects, drought. And those increases in disturbance plus some shifting species distribution across the landscape could allow for the establishment of more non-native species. And if we have more disturbance overall, we're likely to have more young forests in the future. So I'm going to turn it over to Dave to talk about adaptation.
Okay. Jessica gave us a really good overview of some of the things that we expect to happen in future decades. And I like the way she broke it out into direct effects of temperature, direct effects of climate change, as well as the indirect effects with respect to disturbance. So in the next few minutes, I'm going to talk about how we might respond to both those direct and indirect effects of climate change in the future. The term that's most commonly used in terms of response is adaptation, climate change adaptation. Now, that's usually defined as a way to reduce the potentially negative outcomes that climate change may have on natural resources. But it's also important to think that adaptation is going to help us transition species and ecosystems to a warmer climate, as well as organizations who manage those ecosystems. Now, I know a lot of folks think this is going to require some kind of wholesale change in how we manage forests in the future, and I don't think that's true. I think it's mostly going to be a fine-tuning of some of our existing practices and perhaps reprioritizing certain practices in certain locations in terms of how and where we do forest management. But this is just another component of long-term sustainable resource management and planning. So we're going to use mostly the same tools. We might use them a little bit differently and in different places than we used to. So let's now take a look at some of the things that we might be able to deploy across the landscape so we can manage for greater resilience in forests as the climate continues to warm. Now, I say resilience, I mean, how can we retain forests on these landscapes? And beyond that, how can we retain functional forests as well? Okay, well, I'm sure a lot of you have heard this term restoration before. It's been around for maybe 30-some years, and it was developed to help guide the management perspective of trying to essentially get back what we had prior to significant impacts of humans across large landscapes. Now, one thing we've used a lot in the past is the natural range of variation, sometimes called the historic range of variation, for things like fire, various forest characteristics as a guide for how we might restore current forests to those conditions. Then typically we have used species as targets for the success of those restoration projects. Now, restoration has typically been applied at relatively small spatial scales like forest stands, so it's had some impacts, but maybe somewhat limited over the big picture. Now we're talking more about this concept of building resilience. I'm not sure we're going to replace the term restoration with building resilience, but we need to start leaning more in this direction in terms of how we actually deploy restoration across large landscapes. First thing we can do here is incorporate climate change. That's a new factor now that wasn't present in restoration even 10, 15 years ago. So we need to consider that as we go through planning and management activities. Instead of using historic range of variation, looking towards only the past, we need to start looking to the future and think of future range of variation as our guide. Historic range of variation probably serves us well. We'd like to at least get to that point, but then we don't want to stop there. We need to continue to move into the future. We need to start thinking maybe a little bit less about species and a little bit more about using forest structure and function as potential targets for the success of our management activities. And we need to do this across as large a spatial scales as we can. We know we have a lot of forests out there that are potentially vulnerable to climate change, particularly forests on the east side that may not have experienced fire in several decades. I would suggest that we need to start thinking more about this concept of risk assessment and risk management in a formal way. I think we all, in our personal lives, we go about risk assessment and risk management just without even thinking about it. We consider our risk to get sick, our risk that our car is going to get in an accident, or risk that our home will burn down, and we buy insurance. So that's a form of risk management. Or we may do some things to protect our property and health to manage our risks. Natural resource managers are also accustomed to risk management. They're always thinking about, what's the probability that insects will attack this stand, or what's the probability that we might get some root rot in here, those sorts of things. And then they take action to try to minimize those risks. So these are just some questions that everyone can think about, not just on public lands, but also small forest landowners. Are there some challenges to meeting your current management objectives that climate change might affect? And how might you modify a management practice? How, in terms of how climate change would affect your landscapes? And then finally, how do those alternative management practices compare to traditional practices? So just go through this as kind of a thought exercise in terms of, what would I have done 10, 20 years ago, and what do I need to do now as we move forward? What I'd like to do for the next several slides is to go through a series of discussions on what I call good management practices. And these will be fairly straightforward, I think. Most of what I'm going to talk about today would be applicable on both public land and private land. And so I hope that you can see the connections to your own particular situation. So the one thing we always start with is trying to do those things that we should be doing anyway, reducing stressors, keeping our forests healthy. So these are things that aren't necessarily related to climate. So if you have non-native plant species out there, cheatgrass, knapweed, whatever, do the best you can to minimize those populations. Identify locations where herbivores might be particularly damaging to a new stand. Reduce runoff and erosion on your roads if you have some problems with that. All these kinds of things, again, that we should probably be doing anyway to keep our forests as healthy and sustainable as possible. So this is where the action happens: regeneration, tree establishment. This is where the big competition happens to determine who are the winners and losers in a warmer climate. Small trees are very vulnerable, regardless of climate change, because they really have to deal with some extreme temperatures at the soil surface, very high during the day, low at night. They have relatively small root systems, so they're vulnerable to low soil moisture at the soil surface. So this is the key element in terms of which species will survive into the future, as Jessica discussed a few minutes ago. As a result, as forest managers, we really need to take good care of our seedlings and saplings. If we can get them, up to several feet tall, if we can get them above the shrub layer, we know that older trees have deep root systems, especially trees like ponderosa pine that have tap roots, and they're much more likely to survive than seedlings. So do everything we can to retain soil moisture, especially during that summer period when soil moisture is low. So this can be done with things like mulch. And you may be thinking, well, I'm going to plant 5 acres. I can't be hauling mulch around that site. But what you can do is you can kick up some of the organic material that's on site around the base of that seedling, and just a little bit of protection like that, or a little bit of shade, maybe with a log. You see a log behind the tree in the upper picture there. Or some people use these things called shade cards, something that will give them a little bit of a boost during those dry periods. And of course, protect from herbivory, which is something we would want to do anyway. But we have to pay attention to all those things early in the stage, or early in this seedling and young sapling stage. Now, this may seem very logical, of course, but we need to focus even more in the future on drought-tolerant species. So on the east side, we're still going to go with our tried and true ponderosa pine for the most part. Douglas fir certainly will still be an important species to keep in the mix. We might start thinking about Douglas fir a little bit more on north and east facing sites as opposed to south and west. But here's just the 4 species that we typically think of being relatively tolerant of low soil moisture. So these will be our good species for the future on the east side. But I don't want us to forget about some of our other minor species, western red cedar, western hemlock, and so forth, may still be very appropriate on cooler, wetter sites. Western larch is another one. So maybe those are species we plant more in ravines, in concavities across the landscape, on north aspects, and so forth. So just being very thoughtful about a little bit more of the fine scale of our landscapes. And I always like to put in a good word for our understory and edge species. We tend to talk a lot about conifers and just focus on them. But if you want, on your land, if you're managing for wildlife habitat, for example, as part of your objective, then plants like serviceberry, mock orange, chokecherry, all provide some additional habitat for other species. They help to create some complexity in the structure of the forest, and they generally increase the biological diversity of the site. They're also very attractive if that's one of your objectives. So keep these good natives that are relatively drought tolerant in the mix. All right, now we're going to get into an interesting topic for a few minutes, the topic of assisted migration. Some of you may have heard of this term before. Another synonym for it is managed relocation. And this is something we start to think about when we're considering planting trees on public or private land. So there are three forms of assisted migration I'm going to mention this evening. Number one is when we are using the current species from a site, but from adjacent seed zones. So they might be from a seed zone farther to the south, lower elevation, or drier. Then we can think about different species that are just slightly beyond their current distribution. And the third one is different species extended a long ways beyond their current distribution. So three different forms of assisted migration here that we can consider. Now, these are my recommendations for how we go about this, at least in the near future. I really support the concept of planting from diverse seed zones rather than just the seed zone in which we're located, because this provides some additional diversity in the genetics of these populations. It may provide some additional benefits for soil moisture, low soil moisture tolerance, and there's a relatively low risk in doing that. We might extend some species slightly beyond their current distribution in some cases if we feel that there's a minimal risk there for insects and disease, and that those species are likely to survive but not become invasive or cause problems for us. At the current time, I don't recommend planting trees long distances from where they currently exist. So, going down and planting maybe sugar pine from California or incense cedar from California, something like that. They might indeed survive. We know they do survive when people plant them, but I don't think I would want to plant 100 acres of them or do this at a large scale. If you want to do it on an experimental basis, I think that's great, but we need to be cautious, number one, about transmitting insects and disease, and also about the fact that in large quantities, some of these species may be sensitive to the local insects and diseases. So we don't know this information very well yet. We don't have good scientific documentation to guide us, and hopefully that will be evolving in the next 20 years or so. And just to show you here a seed zone map for ponderosa pine. Each of the names in darker green there indicates a seed zone. So if you're living up in the Okanagan region, you might consider planting ponderosa pines from Chelan seed zone, or even farther south in the Yakima and so forth, just to diversify your mix of that particular species. Another form of diversity is multiple species. Quite often when we do reforestation, we stick with maybe one species. Use multiple species if you can, if it's feasible, if it's logical for your site, and also diversify the structure a little bit. So we don't just have one uniform structure and one age across large landscapes, which makes our trees vulnerable. So closed canopy, open canopy, maybe some multi-level canopies as well. And then look across large landscapes. If you're dealing with a big area of several hundred acres, we really have an opportunity there to diversify the pattern across that landscape in terms of vegetation age and structure, and we can orient the location of those treatments in big patches. So this does not mean that everything has to be diversified in every single acre of land, but it should be more diversified at large scales. And then in terms of looking at perhaps smaller landscapes, being very thoughtful about some of the microsites that we have when we're tree planting. If you're planting on a ridge versus in a drainage versus on a side slope, that really might affect which species you put there, as well as the density of planting and the density of trees in future years. Now, the number one thing we always stress to, especially for our small forest landowners, is keep your forest healthy. A healthy forest is much more resistant to stresses that are caused either directly or indirectly by climate change. And competition is the thing that will weaken trees the fastest in most cases. So we need to keep the density managed to a point where the trees are vigorous out there. We need to remove surface and understory fuels where that's feasible and relevant, so we don't have high intensity fires in the future. And to do this in coordination with neighbors, whether it's public land or private land, so that we end up with some very large patches across the landscape rather than just an acre or two at a time, which really doesn't do us much good when we're talking about large wildfires. Now, thinning is something that a lot of landowners think about, and they wonder, well, how should I do this? What's the proper density and so forth for the future? And there's no real recipe for this. There certainly are some good guidelines. But one thing that's been mentioned more often recently is this concept of variable density thinning, where we might have a certain percentage of open stands versus dense stands versus kind of a standard thin prescription across a large landscape. We don't have much scientific evidence to base these recommendations on, but we do have some intuition that this might be preferable in terms of creating some gaps to reduce fire intensity, as well as to perhaps diversify wildlife habitat for some animals. No rules, it's all flexible. A lot of people are trying different versions of this across the landscape. And I'm just going to close out with some brief comments on fire. You're going to have some additional speakers here this evening who will provide much more detail on fire. So we're not going to spend a lot of time on this, but we can't talk about climate change without talking about the importance of fire safe management, because this will become increasingly important in future decades. So do the things that are kind of common sense and helpful for the firefighters out there in terms of access and egress. Provide some open space for fuel breaks. Make sure we work on fire-resistant structures. Again, I want to stress this concept of working at large spatial scales. If one landowner on his or her 5 acres does a good job, but nobody else does around them, again, it's not very effective. So develop some plans with your neighbors and with local communities. There's this concept of fire-adapted communities that's starting to spread slowly in Eastern Washington, and I think that's a great way to go. And we can also do some things around homes and structures to reduce fire spread by managing the vegetation properly, basically spacing it widely near the structures, and then you can get a little bit more dense as you go away from the structure. Now, there's a huge amount of information on the FireWise USA website. I would point everyone to that particular website. Take a look at it. Just Google FireWise USA, and you'll find most of the ideas and tools that you'll need to reduce your fire risk. So we will wrap up here. Here's things we expect are going to happen in the future. It's going to keep getting warmer. If we don't do something to bring down carbon dioxide emissions very quickly, it will get warmer faster after 2050. Droughts will be the biggest thing we need to pay attention to, and we expect they'll become more common, and they'll get longer, and this is what will create stress for our forests, especially at younger age classes. Insects and pathogens will probably be able to take advantage of this increasing stress in forests, and we'll have a longer fire season, which means we kind of stretch out that early summer and late summer period for fires to occur. Now, fortunately, there's a lot of good things we can do, and I really like to end on this point. These are things that we can do to reduce some of the negative outcomes. First of all, as forest managers, we can start thinking about 30 or more years from now as we stick that tree in the ground or as we do our thinning. Think about higher temperatures and more extreme kinds of events like fires. Diversification is our friend here. Diversification of species, genetic diversity, and then diversity of spatial patterns across the landscape. If we do get a big wildfire or have some other type of disturbance like insects, we need to maybe transform our thinking from that being a disaster to being a potential opportunity for doing some things differently out there and changing the trajectory of those forest stands. Again, as I mentioned earlier, think about risk assessment and risk management in a structured way. And then we need to pay attention to what we're doing across the landscape and monitor the effects so we can learn from it and then share that information with our neighbors, as well as adjust our own management practices if necessary. So we'll close out there. On the closing slide, we have indicated our email addresses if folks would like to send us an email about the things we talked about this evening. And with that, let's go back to Darren.
Well, thank you to Jessica and Dave for the excellent presentation. And looking at, I don't have any questions in the Q&A or the chat box right now. We'll encourage everyone in the audience to please take advantage of having both Jessica and Dave's experience and knowledge here to feel free to ask questions and take advantage of them while we've got them here for a few more minutes. So they're happy to field questions. So please do so if you've got any. We'll pause here for a minute or so, see if I can get any questions here in the chat or the Q&A. Today I have one question popped up was, do you have a source for buying tree seedlings?
Well, I get most of my seedlings from the DNR Webster Nursery in Olympia, and they're essentially the supplier for the whole state, and they have everything broken down by seed zones for different species there. But I know there are other places that's including private nurseries and so forth that sell seedlings. So Darren, you may know more about that than I do.
Yeah, my answer would be about the same as yours. Yeah, there are a lot of private nurseries around, but DNR is a good source.
And many of the conservation districts these days do an excellent job on tree seedlings, as well as all kinds of other shrubs and other perennial plants, natives, that you can purchase at usually really nice material at fair prices.
That's true, Dave. Yeah, that's a good point, because often they'll have like they'll have like special event like tree sales and stuff, and have those every once in a while. Some of the conservation districts I know do that. So yeah, that's a good thing to watch out for as well. We do have another question popped up here in the Q&A. Dave, do you have a source for assisted migration so we can explore our local seed zones?
I'm not sure what that question is asking. Maybe Darren or Jessica, do you understand that better?
Well, there is a tool called the seed lot selection tool that can help you explore current climate for a given location, and then what would be appropriate in terms of seed zones for future climates. And you can see where there's overlap between those two. So I can put that in the chat, the link for that one. That's a good one to play around with. We should be coming out with a guidebook to help people walk through that. But you can play around. It can be a little bit difficult to determine exactly what to do, but it's worth playing around in that. And we're happy to help if you can't figure it out.
Yeah, that is a great source to look at things, and you can actually, play around with it a bit and just see what it says. As a general guideline, I guess at the current moment, we generally recommend that folks look one seed zone south of where you're currently located. You know, maybe 2 seed zones south, probably not much beyond that at this point. So there should be relatively low risk in doing that. And that doesn't mean you should plant necessarily all of that other seed zone. I know in my own forest property here in Northwest Washington, I've mixed it up with the Skagit seed zone, which is where I live, with the Puget Sound seed zone, which is farther to the south, about 50-50. So that, again, there's some just diversification in there. It doesn't mean we have to go whole hog on something new, but just to mix it up a little bit.
And the person that asked that question did put in here, yeah, there are any article sources or tools for assisted migration. So yeah, you did mention the seed selection tool. So if there's any, I guess if you two have any other articles or sources, you know, web sources or anything that might be that the audience might find useful, maybe if you could share those in the chat, or I think that's what they're looking for too. Let's see, next question here. I would like to diversify my forest border under a power line that was cleared. What good shorter growing natives would be good? We have lots of fern and snowberry, some Oregon grape so far, and a few noxious weeds.
I'm glad to hear a few associated with noxious weeds. Hopefully they won't take over. I love snowberry. I love Oregon grape. I think those are good ones. They're relatively drought tolerant, which is good. I think the other natives that I mentioned here today, serviceberry can get a little bit taller. Choke cherry can get a little bit taller, but mock orange generally stays under control. Beautiful plant, so I think those would work quite well in that situation.
All right, thanks, Dave. Let's see, one more question here. How much work would you put into keeping seedlings alive, i.e. watering going as far as watering seedlings?
Wow, if you can water seedlings, do it. That's like the best thing you can do. You got to get those little seedlings beyond the first couple years. So if you have a way to get out there in the woods and water them, absolutely do it. And it doesn't mean you have to do it all the time. You know, you can wait till there's been, you know, maybe a month of dry weather or whatever, then go out and give them a good drink. I don't think it's something you want to necessarily do every week, but you may not have to do it at all if you have some good rainstorms during the summer. But yeah, that's a wonderful form of insurance, that and mulching.
Okay, that catches us up with the questions in the chat and the Q&A. We'll pause again here and see if we get any other questions here. Well, not seeing any other questions pop up, so I guess I'll just do on behalf of everyone a nice virtual round of applause and thanks to Jessica and Dave for joining us this evening and taking time out of your schedules to join us this evening and impart and share some of your great experience and knowledge that both of you have. Really appreciate it. Oh, we do have one other thing in here. The web address for the nursery in Olympia. So we're talking about the DNR. Oh, DNR is not in Olympia. The nursery is not in Olympia.
I think I found it. I'll put it in the chat here.
Okay, I was going to say otherwise I can check it down, but okay.
Yeah.
Oh, there we go. Thanks, Jessica.
Mm-hmm.
All right. Well, not seeing any other questions. Once again, thank both of you for being here for the presentation, and we'll go ahead and take a 15-minute break. Give everybody a chance to get up and stretch, get away from computer screens, get a cup of coffee, get a snack, whatever, and come back and be ready for our next presenter. And we'll come back start up again at 7:10. And we'll see you all back in a few minutes. Thanks. Well, welcome back, everybody. Hope you had a nice break, got a chance to get up and stretch. So we'll move on to our second set of presenters. And we were talking about fire and fire season, and it's had its impact on our planning for our presenters for this series. We've kind of had a last little bit here of a mix-up over I should say not a mix-up, but a adjustment to our speaking schedule due to people being on the fire season still being active and people being on fire assignments. So we've got a couple of people that graciously were able to kind of fill in here at the last minute to talk on our prescribed fire and smoke issues. So first up, we've got Matt Eberlein from the Washington Department of Fish and Wildlife that'll talk about prescribed fire. And then we've got Vaughn Clark from the Department of Natural Resources that'll talk on smoke management. And I'll go ahead and turn it over and get Matt. I think you should be all set up to go ahead and share screens and go ahead and start your presentation.
All right. Can you see that okay, Darren?
Yep, I can see your first screen. Yeah, your first slide. Yes.
All right. Well, thank you. And I really appreciate this opportunity to be able to share this presentation with everybody. I think I can tear off of Jessica and Dave's presentation pretty well. But tonight I want to talk about the intentional use of prescribed fire as a management tool. You know, it's one of many tools that we can use in our landscape, but it's a very effective one, and especially when we're talking about areas like Eastern Washington and East Slopes of the Cascades, where fire happens. It's going to happen with or without us, but how do we want it to happen is the million-dollar question. There we go. So, like Darren said, I work with Washington State Department of Fish and Wildlife, and we have some forest management missions that we try to work with, and it's preserve, protect, and perpetuate our forests and fish and wildlife habitat so that we have this sustainable, recreation and commercial opportunities. And we want to try to continue to have that. We want to take a look at this and our mission and how we manage it for, what both the ecological integrity, taking a look at priority species, and then what kind of risks are out there, and in the previous presentations, they talked a lot about wildfire, and this summer there was a lot of fire on our landscape, and some of the areas that I'm going to talk about tonight saw a significant amount. So again, it's how do we want to see this fire used or on our landscape? So first question is where would we use prescribed fire or some kind of a treatment like that? And well, we want to take a look at areas where stands are overstocked and maybe there's a health and disease issue. In other areas where maybe other land management practices have taken place, such as a commercial harvest, where they've removed timber, or just a pre-commercial thinning, thinning out that stand density. And maybe where the ecosystem would have saw regular fire intervals, it came in on a routine basis, 5, 10, every 30 years, something like that. And can we apply fire like that? Or where it has been excluded. So to start with, we take a look at the fuel loadings, fuels being the vegetation on our landscape. So here's 3 pictures that kind of show the differences, and not starting on the left is an area where it saw some commercial harvest. There's a lot of slash residue there. And that might be a prime candidate to go in and burn. You might say, how in the world are you going to burn that without burning up everything? And that's a good question, and that's been asked.
Hey, Matt, I don't hate to interrupt you for a second, but you seem to be kind of fading in and out every once in a while on your audio.
Move closer, I'm not sure.
That might be because it sounds like you're kind of getting closer and then further away every once in a while. So
okay, well,
sorry to interrupt you there, but
oh, not a problem. You never know if it's so. This is okay.
yeah, right now you're good again.
Okay, thank you. Sorry about that, folks. Okay, so on this left-hand screen, you can see the heavy vegetation or heavy fuel loadings. The center is moderate. Maybe that's had some commercial harvest that has taken place. Might have seen some fire several years back. And then on the right-hand side, that area had seen some fire. You can see a little bit of dark patches on the bases of those existing trees. But you can see the stand, the canopies are open, trees are spaced. And, fire can be managed in that landscape a lot easier. If we leave it like the photograph on the left, that's just going to be hard to manage. And if we get too much of that, you just can't. And then that'd be tough to plant trees in and reforest and things like that. So we take a look at, with that fuel loading, what kind of fire behavior do we want? So 2 photographs here, you can see some prescribed fire being used on one of our wildlife areas in northeast central Washington. And then the Clockham Tarps wildfire in 2013. Take a look at the flame links in those 2 photographs. You've got 2-foot flame links on the prescribed fire unit and 200-foot flame links on the Clockham Tarps wildfire. A whole lot easier to control those 2-foot flame links. And also using prescribed fire, we pick that time of year when we can maintain that. So we're gonna burn in the spring or the fall when we have higher fuel moistures, weather that isn't as hot and dry or erratic. And we can control our fire a lot easier and pick those locations where we put it on our landscapes. It's a great tool. So here's just some information based on WDFW lands, that forested areas that require frequent fire. And you've had your western larch savannas, and ponderosa pine stands, Douglas fir, and so on. But it's not just conifer forests, that respond well. Some of the deciduous forests like aspen and oak forests also do quite well with routine fire, maintaining that vegetation. A little bit of disturbance with some light fire can really help your aspen stands pop. So if you've got, say, an older generation aspen stand and you put a little fire through it, you'll see a lot of new growth pop up just from that disturbance. You gotta love this photograph. Not too many face cuts you can sit on a horse in. But what our forests are a lot different than they were at the turn of the century, mid to late 1800s. But you take a look at that and you think about how our forests are a lot different. What were they like, back before population really started growing in the Pacific Northwest? What kind of stands did we have? They saw regular routine fire. Prescribed fire has been used for centuries, but even lightning strike fires and things like that came through our landscapes, different mosaics of tree stands, openings, and thinner areas. These trees didn't get big just because. It was fire came through, or they did grow in an area where maybe there wasn't a lot of fire, but suppression came in. So, you know, just the growth of the Pacific Northwest was heavily influenced by timber harvesting and these great trees that we had back in the late 1800s, 1900s. But as folks moved into this area, population growth came in, commercial industries were popping up, and suppression became more of an effort. So that changed our forest structure, the composition of our forests, where we started to exclude fire, suppressing them more frequently, more rapidly. And because of that, we saw our forests change. They started to get denser, more accumulation on the ground of dead and down, more vegetation, more leaf and needle litter buildup, which intensified our fires. Throwing climate change on top of that, you know, you've got a bad recipe going on. I'm sure these next series of slides, a lot of you have seen, but here's a stand in the early 1900s that, you know, some harvesting took place. You can see the stumps in there. You can see some piling going on. They used a little bit of fire in there. Some of those trees do have some black stumps on them, so, or bases. So fire came through this area, but the stem spacing is pretty good. The canopies are open. It's ponderosa pine, so it's a good fire resistant species, just like what was talked about in the previous presentations. And so that's a great stand and pretty fire resistant. More of what our grounds look like. Now the next one, 40 years later, that big tree's still in the foreground, but now in 40 years, you start to see a lot more growth coming in. And then another 40 years later, all the big trees are gone. But now you've got not only ponderosa pine, but some Douglas fir and maybe some other species in there as well. They're all little. It's just a dog hair thicket. There's ladder fuels all the way down to the ground. And what we're not sure of in these photographs is how much debris is on the ground as well. You know, maybe there's still some of that logging residue. I like this painting. So mid 1800s, here's a painting, maybe a little bit of artist privilege in there, but nice painting of the Yosemite Valley. Now you have modern Yosemite. I'm going to bounce back on that one just so you can take a look. So here's a painting. Notice the valleys are a little more open, a little more broad with vegetation, and now it's starting to close in.
Hey, Matt, you got a little bit of that audio dropping in and out. I'm not sure if it's your distance or if you've got something with your mic or something that keeps kind of muting out and then comes back to normal audio again.
I'm sorry, I'm not sure what I can do to fix it. I'm setting practically on top of my laptop.
Yeah, it must be some other technical issue going on. So, all right, thanks, Matt.
I'm sorry about that.
It's okay.
I can try speaking a little louder. So where is it necessary to treat? Where fire provides benefits to the ecosystem, where maybe the species that are out there or the habitat will benefit from that, maintaining those forest structures, where the fuels and terrain are conducive to the use of fire, you know, where it's not on a steep slope, where it's really difficult to hang on to that prescribed burn or apply fire safely, but more in terrain that will allow it, and also that vegetation will allow it. And then maybe where the wildland urban interface, or WUI, is in place. Now that sounds potentially a little risky, you know, putting fire on the ground near homes and private property, but maybe in a combination of tools, you know, to manage that forest, it might be possible. Now, WDFW lands does border a lot of private property, and we have successfully burned quite a few acres where we are actually really helping that defensible space for those private lands. And then we've even given them some advice, and DNR has stepped in to help with some landowner assistance advice and funding to support their lands. But here's a picture. These examples are everywhere. You got these nice little pine thickets, and there's a house right above. Here's some photographs taken by Frank. I never get his name right. But early 1900s, Sinlaheakin Valley, again, up in the north central, North Washington. And you can look at these slopes and notice that the tree density is quite a bit thicker in the later photographs in the 2000s, 100 years later. But you can see that they're starting to encroach down into the valleys and get a lot thicker in that density. Again, just another photograph of the Sinlaheakin, about 100 years apart, and same area, and it's just filling in with timber. Notice the stream bed is dry. Now, that stream bed may have just changed locations over time and switched into a different spot. I'm not sure the story behind that, but you can see it's filling in. This photograph is down in the Glenwood, Washington area, southeast central Washington. And we did some mechanized treatment on some state land and some mastication, chipping, thinning, and pruning. And, you know, we were a little bit challenged where we couldn't take anything over 8-inch diameter DBH, but we were able to thin that out and then make this a lot more easier to use some prescribed fire in. And then what you can't see is just off to the right is about 100 yards out is private property and barns and homes and other infrastructure on private lands. So you can just kind of picture how a wildfire would run through that upper photograph versus the lower one. And then you throw a little prescribed fire in there and really clean that up. We didn't stage this photograph. I didn't pile a bunch of brush in front of the camera before I took the picture. That was actually the vegetation that was there, and right behind it, I'm only about 30 or 40 feet from that structure, but doing some defensible space for these folks and cleaning that area out really helped improve that. They're able to see wildlife out there. They really enjoyed it, and it looks pretty good. So, you know, I started off talking about what kind of fire effects do we want to see on our landscape. I think these two pictures pretty well explain themselves. On the left, on our Sherman Creek Wildlife Area over near Kettle Falls, prescribed fire has been used for a lot of years. Different forest management practices with commercial and pre-commercial thinning along with prescribed fire. And then down in our Wooten Wildlife Area, down in the Blue Mountains, east of Walla Walla, this was effects from the 2000, mid-2000 fires of the school and the Columbia Complex. Back-to-back fires, 2005, 2006, and devastated over 150,000 acres and over 200 structures, about 250 structures roughly, were destroyed in these two back-to-back fires. And as you can see in that photograph, it's just literally wiped out that landscape. And 10 years later, and you still don't see a lot of vegetation regrowth in there. So again, prescribed fire, picking that time of year and when you want to apply it can really help. Here's a couple of photographs where we've done some mechanized commercial harvest and then prescribed fire about a year later. But the bottom picture is this year and the Cub Creek fire that happened in the Met House. This happens to be on one of our prescribed burn units. And where I'm standing, where I took that photograph, is the dozer line where they did some suppression action. And on the right-hand side of the dozer line, you can see the fire burn through the area and burned a little hotter than I would want it to burn in a prescribed fire fashion. But you can see that it burned everything on the ground. It scorched the trees up pretty high, probably overheated those cambium layers. So those trees probably won't do very well in that. And then on the left-hand side of that is where we're going to burn here in hopefully the next few weeks, which becomes a bit of a controversy where you think about, well, gosh, these folks have seen out in the Met House, they've seen fire all summer long. And now you're going to put fire on the landscape. But you can see what kind of devastation it does. And we don't get a lot of windows in the Pacific Northwest to burn. We burn in the spring, we burn in the fall. The windows really aren't all that large, where the opportunity is just right to put some fire on the ground. And we can get the effects that we want, where we clean up the ground, but we don't devastate the landscape and we keep it in our box. But fire has proven multiple times on our landscape where we have applied prescribed fire and then wildfire has come in. And I've got some photographs coming up. But here's just some more impacts. So we've got a lot of erosion impacts where it burns off that vegetation and then water comes down in the spring. Look at that bottom picture where the mud layer, water layer is on that little shed and all that debris piled up against that truck. The banks are washed out. So the fires that we're seeing anymore, they're burning hot, they're out of control, they're burning a lot more at a higher intensity than we would want. So some drivers that we look at are this lack of routine fire intervals. We've seen some, and this is on DFW lands that we're talking about here. We've seen a lot of high grade logging. DFW has inherited a lot of lands that came from other ownerships where they've taken out all the good timber and left more of the trashy timber, or taken out too much. Lands that saw low percentage of types of treatments. Maybe they took out all of the good timber and then they just left it, didn't thin it, didn't apply any prescribed fire or burn the piles. We're seeing an increase of acres. You saw that in Jessica's presentation where she showed those charts where we're seeing more wildfires. They're more intense and too intense. And our forests, the way they sit right now, aren't really ready for these uncertain climates that are coming up on us. And we need to try and change that, put fire a little more routine on our landscapes. And we want them in a prescribed fire, you want in a low intensity, but we're going to have wildfires. Well, we want to see that in a low severity. So low intensity, low severity burns. Just on WDFW lands, we need to treat somewhere between 10 and 30,000 acres a year with the right appropriate treatment, whether it's the appropriate intensity of fire or some harvesting, thinning, maybe a combination of all of those. And we also need to focus on these high risk areas where life and property are at, priority species, that ecological integrity, watersheds, areas like that that provide a lot of infrastructure for the rest. So taking a look at the ponderosa pine wood savannas that we see a lot in Eastern Washington, we've got overstocking, density. I think I saw the slide where there were too many straws in the glass. That's the good picture in the upper left. And we want to get that down to a more desirable landscape like what is in the lower right. Thinning alone is not enough. This was an area on the Sinlahican. It was logged in 2014. You can see the stand density. It's pretty nice. When that was alive, you got some good density, nice sized trees. And then in 2015, a year later, the slash had not been burned yet. But in 2015, the Okanagan complex came through. Our intention was to burn that between the fall of 2015 and maybe the spring of 2016 if necessary. Well, that wildfire beat us to it, and you can see that it hit it pretty hard, burned it a little too hot, too severe, and scorched those crowns out. We lost a lot of that timber, and it's unfortunate, but it beat us to it. Again, just another picture of thinning and prescribed fire combination. And that is actually the way it looks there on the Sherman Creek Wildlife Area when you go up Highway 20 out of Kettle Falls headed towards Republic. It's just beautiful. We're seeing more native grasses. We're seeing more shrubs to help our wildlife that feed on that area in the wintertime. And it really helps. There's a lot of shrub species that are fire dependent, like bitterbrush and ceanothus, that will really spring up when you run a little bit of fire through it. Again, just another combination of thinning and prescribed fire use. But what it does is it makes that a very fire resilient landscape at this point. And again, like I said, we've seen that in 2015, 2018, where some fire hit our landscapes. This was the Okanagan complex in 2015, where the suppression crews actually used our hand line where we did burning on the right that spring, and the wildfire came down and they utilized that fuel break to control that flank of the fire. And again, that happened in 2018 on the Boyd's fire near Kettle Falls. And it was very useful, very helpful. And in that landscape, you actually can't even tell where that fire got into our prescribed burn, those wildfires, that you really can't even tell that it did anything other than act more like a prescribed fire. So costs can fluctuate for a lot of different reasons. Terrain, you know, what are you working on? Fuel loadings. What I don't have in here is water. We move a lot of water from creeks and things. We have to get it to our areas that we burn in. So again, the resources needed to manage that prescribed fire, whether it be water resources, people power, other equipment. There are some smoke limitations to it. I know Vaughn's on and he's going to talk about that in a bit. But, you know, that seasonal timing and the smoke limitations may play a factor in that. The last thing we want to do is smoke out a community or a highway or something like that. So we need to try and time that the best we can. And again, you know, I've talked about seasonal timing. We'll burn in the spring and the fall when our fuel moistures are right and our ground moistures are right. But as we start to get into the later parts of the spring, we have to add more people, more resources, spend more time on that fire, that prescribed burn, and the costs go up. So earlier in the season, costs are fairly low. Later in the season, costs get high. Here's just some average costs that you can throw at this. They are kind of all over the board. But, you know, mechanized chipping, mastication, things like that can range anywhere from $500 to $2,000 per acre. Pile burning is fairly affordable. but you have to handle that material quite a bit. And prescribed fire, right in that same ballpark. But compared to the cost of wildfire, oh, you're saving a lot of money if you can do one of those treatments on your landscape. But prescribed fire and pile burning are very effective and pretty cost effective. And if you have the capabilities yourself, you'll save some money there. Again, just some of the impacts and restrictions, that seasonal timing. Are there some burn bans in place? Maybe some smoke restrictions that are in due to inversions, or the air shed is not pushing it out very well. Are there some restricted use of public lands and areas? So on Fish and Wildlife, you know, we're also managing hunting seasons and fishing seasons that get high use in those areas that we burn in. That definitely plays a factor in it. I'm getting ready for our fall burn season, but so are the hunters for elk and deer and things like that. And I get a lot of nasty grams on that. But what we're really trying to do is improve those experiences out there in the landscape. I've had the same group of hunters call me and not be very happy about our prescribed burns. And then the next year they call and say, that's great out there where you burned. I can see, I can walk, I can get around quietly. So it's kind of interesting. There are some liabilities to it, you know, with the fire, putting fire on the ground, applying fire, that's risky business. And it causes a few gray hairs on me, but you know, I know DNR's got some programs that they're working on to help educate private folks and help with that. And then we're always willing to talk as well. You know, maybe experience is an issue. I know just in the agencies alone, trying to get qualified burners, I have quite a few people that work for me across the state in this program, and getting qualified folks to come work for me is, it gets a little tougher. And of course, funding is always a factor. It costs money to do it, and that cost has to be there, or that money has to be there. So in summary, I guess for folks that are thinking about this, you know, what type of management practices work for you? Maybe it's a combination of practices. Maybe it's some thinning, some pile burning, some mechanized work. You want to look at reducing that risk on the landscape. That's what we're doing. Forest Service, DNR, we're all trying to work together to what we would say, you know, connect the pieces of the puzzle so that we don't have these breaks in our landscape and ecosystems. There's some available funding out there for private folks through their landowner assistance program with DNR, conservation districts, RC&D. They all have some different avenues out there that can help private landowners. And then again, you know, training with the use of fire. You just don't want to do it without a little bit of background, some experience. There's a lot of folks that you can talk to, whether it's Fish and Wildlife or DNR. We're glad to answer questions and help, and DNR's set up pretty well to answer those type of questions with those private landowners. And again, you know, maybe some different education processes and ones like this with the WSU extension. Great tools out there. That's what I've got, Aaron.
All right. Thanks a lot, Matt. Appreciate the presentation, and especially appreciate you being your willingness to help be a substitute presenter kind of at the last minute. Really appreciate that. So if people have questions for Matt, if you want to go ahead and start putting stuff in the Q&A in the chat, we'll still go ahead and kind of still have save our Q&A time to the end after we have Vaughn go ahead and do his presentation. But if you've got so you don't lose track of your questions, go ahead and put them in there into the Q&A and chat, and then we'll just come back to them here after we roll into after Vaughn's presentation. So we'll go ahead and shift over to Vaughn if you're ready.
Right.
To ready to go there. And
Yep.
sorry, Vaughn, I don't know, since you were a last minute fill in, if you want to, I don't have a bio for you at all. So if you want to also kind of tell people a little bit about your background real quick, that'd be great too. When you start
Sure,
off.
sure. Can you hear me okay?
Yep, I can hear you great.
Okay. Yeah, so my name is Vaughn Cork. I'm the Fire Regulation Program Manager for the Department of Natural Resources here in Washington. I've got charge of the smoke management plan, and with that, how we make decisions for burns that go on, and within that too is the burn permitting program. So since this was a little bit last minute, this is a presentation that Carolyn had put together. She works for me as the smoke management field coordinator, does most of the decision making for our approvals on smoke, yeses and nos when we have large burns going on. So some of these are, you'll see her name at the end for things, but get right into it here. So, and some of this was also set up for federal prescribed burn refreshers. So I'll skip through a few of these slides in here, but basically smoke management for the state, anytime we do any kind of silvicultural burning, wildfire risk reduction burning, anything like that, it falls into DNR. And what we have is, we're a very small portion of what DNR does. There's the wildfire portion of things, there's a forest health portion of things, geology, all that kind of stuff. We work that little bitty corner of smoke management in with policies and rules set by the Department of Ecology, who's in charge of the Washington State Clean Air Act, and then to a lesser extent with the local clean air agencies. So across Western Washington, there's local clean air agencies covering pretty much every square inch of ground. Department of Ecology doesn't maintain much of that, but across Eastern Washington, Ecology is a pretty big player. But then you also have Spokane Clean Air and Benton Clean Air and Yakima Clean Air agencies, and we work with them to manage the air sheds. So why do we have smoke management? Why is it a thing? I don't remember the years exactly, but EPA's Clean Air Act, the Federal Clean Air Act came out and said states need to come up with something to manage their own emissions. Long time ago, back in at least the early 90s, Washington had developed its own Clean Air Act to go on top of that. And with that, the Department of Natural Resources developed a smoke management plan that was submitted to EPA and approved, and it's one of only a handful of federally approved smoke management plans in the country. Most of the states out there have a handful of rules and procedures. We've actually got one that's been approved by EPA. Part of that, part of the rules and regulations that we have set up inside that smoke management plan are set up to meet the Clean Air Act regulations from EPA along with the State Clean Air Act. We also have what's called the Regional Haze Rule, which is basically, think of a good way to put this. Basically, how far you can see in an air shed. So if you're standing at the top of Mount Rainier, how many miles of visibility do you have? And for various corners of the state, wilderness areas, national parks, things like that, we have to maintain this regional haze levels so that the air quality, the visible air quality, maintains a certain standard. The other portion of things, why we have this plan, is for protection of human health and safety. Matt talked about it, like folks have been dealing with fire all summer long. Some places like the Methow Valley have had multiple days, year after year after year, of dealing with wildfire smoke. And when we go into prescribed fire season, doing those management practices that make sense, we want to make sure that that we're not having a negative impact on human health and safety. So, and that comes from inhalation of smoke particles. We do have instances of super fog generated by smoke. So you get smoke dropping down into a drainage, combines with fog, and then you can create basically zero visibility conditions and cause car accidents if you're not careful in managing that. And then there's also the public perception of smoke. Again, people have dealt with it all summer long, some for years at each summer, and we try to do our absolute best to make sure that we don't have negative impacts for people in that respect. So we have the plan that we're working under right now was completed in 1993, revised in 1998. We're currently under another revision right now with several different updates and improvements that we think will be pretty good for burners while maintaining, good clean air. We're trying to get that through EPA right now, but right now we're still working off the 1998 revision. Some of the things that we're trying to get with the new smoke management plan, we've had for years and years, since 1993, we've had a prohibition on burning from June to October on the weekends for large burns. So that's over 100 tons of material. It was there to meet regional clean air or regional haze rules. We've basically been able to show that it doesn't have any effect due to fire danger, fire seasons. We're not really going to do all this stuff. And all we're doing is hamstringing some of those burns that we have the opportunity to take advantage of in, like September, when we do have some burn windows open up, but they might be pretty narrow. We've also looked to change intrusion language, which for those of you who are not familiar with, that's basically if we have an instance where smoke makes it into a community in an amount that's unacceptable, other than basically just briefly being able to smell it. We've changed our language on that so that there's some, solid sideboards for what an intrusion actually is. It's a lot less subjective. And then for the last 20 some odd years, we've been required to make our decisions on large burns the morning of. So if you wanted to burn tomorrow, we'd have to make the decision somewhere before 8 o'clock in the morning, tomorrow morning, but no sooner than about 6 a.m. So we have a pretty narrow window to make sometimes a whole lot of decisions in there. And we're looking to get that to going for the afternoon before so that people can, put in for their burn, get a yes, get a no, be able to, pull resources together that they might need, especially for some of these like community organizations that may be developing and getting, multiple landowners burning at the same time and combining their resources. Those sort of day before approvals would be more beneficial so that people can get their stuff that they need to be able to get their burns done. Let's see here. So there's a lot of goals and objectives of the smoke management plan. You can read through these. I'm not necessarily going to go through them verbatim, but the priority is protecting human health and safety from the effects of smoke while still allowing burning to occur. Let's see, we can skip the federal process because we're not here for that one. So burn costs. DNR's program for burn permits is based on basically it's a pay to pollute system. So depending on how many tons of consumable material you have, so how many tons of wood you're looking to burn on your property or grass or whatever it might be, you fall into the fee schedule. Most private landowners who haven't undertaken their own timber sale end up in the 100 ton category or sub 100 ton, and it's 105.50. Once you get above that, then it starts getting substantially more. But if you've got 5,000 tons of burnable debris, then you either had a really, really, really big timber sale, or you've got a whole lot of land to cover that hasn't been treated in a long time. That's some pretty extensive fuel loadings for burns of that size. Some thresholds and requirements. So we have this 100-ton mark. It's sort of the magic number for a lot of things. It's every burn permit that's issued for less than 100 tons is all the same fee. Any burn that occurs that's smaller than 100 tons for a single event. So it could be, it could be a 15,000 ton permit, but if they're going to burn less than 100 tons on any given day, it doesn't require a specific smoke management approval. So you make your calls, your notifications that are listed in your permit, and provided that there's no burn bans in place, clean air or fire danger, and you're meeting all the conditions of your permit, you're good to go. If it's over 100 tons, then it has to go through our smoke management shop to get an approval. Basically, we look through the atmospherics, we look through the meteorology, where you're burning, all that kind of stuff, and give a yes or no. There are some low risk areas. I'm not really going to go through that because most of the folks here would be relatively urban and wouldn't fall into these low risk areas. So I'm not going to read these either. You guys can read through this stuff on the screen, but basically there's 8 approval criteria that we have to make whenever we give a yes or a no. Do we think there's going to be an intrusion? Does the meteorology show that we're going to send smoke into a community? Yes or no? Do we have a special public event? It's a pretty unrealistic scenario, but if we were to send smoke flowing down into what used to be Safeco Field, I don't remember what the name changed to anymore, but during the middle of a Mariners game, that would be a really bad thing. It would be a special public event we would try to avoid. That's an extreme situation, but that's one example. We have to maintain for class 1 federal areas. That's the visibility protections. We have to make sure we're not violating any other federal air quality regulations or laws. So we have emissions caps that we're required to meet, all that kind of stuff. At some point in time, we haven't gotten here in decades. We have a mandatory emission cap that was set back in 1989, where we are not allowed to exceed that cap. We actually had to reduce it by 50% by, I want to say it was 1994 or something along those lines, or 2000, excuse me. And we've never come close to bumping that since 2000. So we've gone 21 years without getting close to hitting our emissions cap. But that's one of the things we have to consider if we ever do get close to that. We're also not allowed to violate other air quality standards from other states. And the final one, this is a really subjective one. Smoke will not significantly disperse within 8 hours of ignition. Unless you're burning grass, there's going to be residual smoke. We recognize that. We don't really shut anybody down for that. We're talking about like none of the smoke from the entire burn was able to disperse from the burn site, and it's just hanging. That's kind of what we think of when we're looking at that 8th criteria for allowing a burn. So we look at, when we do have to make decisions on burns, we look at every individual burn. We're looking for the current air quality. We're looking for what type of burning is being done, because a broadcast burn creates more emissions per ton than a pile burn, just due to combustion efficiencies. We're looking at what the meteorology says. What winds do we have? How well is the smoke going to disperse? How far are we from sensitive areas, communities, things along those lines? do we think the smoke is going to disperse by the time it reaches one of these communities if the winds are pushing it that direction? We use a lot of tools to come up with this stuff. Every one of these is linked on our burn portal, which we'll get to in a minute. But every single one of the tools that we use is available to the general public too. So if you're concerned about any of these pieces, you want to know what the air quality conditions are, you want to know what the atmospheric conditions are that we're looking at, it's all available. And like I mentioned, all these things are linked on the burn portal. This is the place to go to get pretty much every bit of information you're going to need to burn. So you can see on here, you can look up every issued burn permit in the state, see where they all are. You can't see all the information on them because some of that is relatively sensitive. But you can see exactly where they are, how much they're for, what they're what kind of burn it is. You can get information on permits, information on smoke, information on how to determine what kind of fuel loads you have if you're trying to do a natural burn or a broadcast burn. If you want to read verbatim what the Clean Air Act laws and rules are, those are linked in here as well. All the clean air or all the modeling sites that we use to make decisions are all linked in here. You've got weeks of material to put you to sleep reading in here if you want. There is also, this is also where you would go to apply for your burn permits. It is a little bit clunky. I will admit that it's not designed for one time or random users. For the most part, it was put together. About 95% of the burning we do is regular repeat burners as far as tonnages go. So it's kind of geared more towards those folks. But if you ever do need help with anything, give us a call, send us an email. We're more than happy to help people through with getting their applications put in. Like I said, we realize it's a little bit of a clunky process and some of it can be kind of confusing, especially for first-time burners. So feel free to reach out to us at DNR and we'll be more than happy to help you with it. But one of the things you'll see once you have a burn permit is we like to, well, burn requests are required for large burns. So you have to get one in or we don't know you're trying to burn and you'll never get an approval to burn. If you've got a small burn, less than 100 tons, we still like to know about them because it helps us make decisions for the really big ones. You know, when we've got 1,500, 2,000 tons, 2,500 tons on a single burn that's applying, it's really helpful for us to know that there's, 25 burns that are less than 100 tons that are going out there that day. And unless folks actually put them into the request site, we don't necessarily know those are out there. Let's see, Fed specific, we don't need to do that. Because we're talking about forest health type burning and forest health improvements to your property, stuff like that. This is an option in here for forest health exemption. It requires a little bit of additional paperwork when you apply for your burn permit, but it does get you some priorities. So if we have 15 burns going on in one location, forest health exempt burns get the priority first. So if we have to say, if we can only afford to approve 10 out of the 15, the forest health ones will get the approval over the non-forest health burns. If we ever reach our emissions cap that I mentioned earlier, forest health burns can continue, non-forest health burns are shut down. We haven't reached that in 21 years since it was put in. So it's not a high likelihood, but it does get you those a couple of advantages. Definitely not required, but it does help. Let's see, multi-day burns. There shouldn't be anybody in here doing multi-day burns. Curtailments. So, that first slide had the Venn diagram of where burning or where the smoke management plan fits. And curtailments is where ecology and the clean air agencies have their piece of the pie. We have zero say in DNR on when a clean air curtailment is enacted. Those are all done by the Department of Ecology and the clean air agencies. But as soon as one happens, we're required to shut down all outdoor burning. So we maintain our 1-800-323-BURN phone line system where folks can call in and find out if there's any clean air curtailments in effect. Also through the burn portal, we'll put those up in there so that people can check and see if they're allowed to burn or not. But there may be times when those curtailments occur after somebody has lit already, and we may end up making calls to have folks, do whatever they can to get it out. Sometimes it's letting the piles they have go and not adding any additional ones. Sometimes it's aggressive suppression. Really just depends on the situation. But those do get called typically in the colder months in the winter when we get some of those clear skies, January, February in particular. We end up getting that stagnant air and have to put the hold on a lot of burning. Let's see. Complaints and intrusions. Unfortunately, wherever there is smoke, there's typically complaints. Depending on the relationship you have with neighbors, proximity to neighbors, sometimes you can get a lot done without having much. Sometimes folks are in a pretty unlucky situation where it's just really hard to get any burning done due to proximities and just due to the general weather in that area. Some places are just prone to inversions and smoke setting in. We'll do whatever we can whenever we get complaints to see if they are legitimate nuisance complaints, or if it's things like neighbor disputes, somebody just doesn't like the burning, they have no reason not to, and they're going to call up every time anyway, and work directly with the burner and the complainant to try and come to a solution. There's some things that y'all can do to help alleviate that. There's obviously there's some conflicts between neighbors that are never going to be easily resolved, but we do like to encourage folks to be forthcoming and upfront about when they're burning, and give people those opportunities to basically change their plans or tweak their plans around when there's going to be smoke in the air. Communication tends to be critical for avoiding those constant complaints. What we'll end up doing from DNR, well, for you all, you can call and email us, the local regions. You can call us in the smoke management shop. We'll work with you to get to give you an idea of when the best days are to burn. We have some smoke management coordination calls that go on twice a week. We can give you an invite to those too. But basically, we want to make sure y'all burn with the right weather conditions to not have complaints, because it's that public license, right? And if we screw it up with constant intrusions and constant complaints, then we face a pretty big uphill battle. Let's see. Documentation, some things. If we do end up with any intrusions or anything like that, there is a little bit of documentation that can help. Most of the time, we're never going to have it for small burns. I can only think of one event in the last several years where we've had a small burn that turned into an intrusion event, and that was up in the Methow Valley. There's no reason they should have been burning that day. You want to keep some notes. If you do end up having any kind of smoke impacts, you want some notes from before, during, after. Basically, you want to find anything where you deviated from the burn plan or from your burn plan. What happened with the smoke? What happened with the weather? Pictures are worth 1,000 words. 5 pictures can be enough to piece things together. So, if things aren't going too well, snap a couple of photos. It's incredibly useful when we have complaints and whatnot for the burner to be able to come out and say, no, look, here at noon, this is where my smoke was and what it was doing. Here's what it was doing at 2 o'clock. Here's what it was doing at 4 o'clock. It never once went this direction, until basically everything was done. Okay, cool. All right. We see what you got there. That's as much as we need. So, have some sort of a documentation on things. Whatever you have in the way of a burn plan, whether it's 5 sentences scratched on the back of a card, or you're like our partners with Fish and Wildlife and the feds, where they've got like 65-page long burn plans. Follow it. If you've got it, follow it. If you don't have anything, then you've got your burn permit, which is technically a burn plan. Make sure you're following the conditions in your burn permit. And then, again, communicate. Call us if you've got, especially if you got a large burner, you got something that's a little sketchy that you don't feel necessarily good about for smoke or something like that. Give us a call. We're pretty amenable to those sorts of things. There's some times we can't answer just due to like meetings and normal fun office stuff, but we usually get back to folks pretty quick and more than willing to help people plan some of these things out and get you through the process. But communicate with your neighbors, make sure the local fire districts, make sure the local DNR region knows that your burning is going on. Yeah, that can prevent a lot of problems. So again, I mentioned I didn't put this one together. My smoke management field coordinator did. Her information is up here, and I'll leave this up. But that's all I've got for you tonight.
Hey, thanks, Vaughn. Appreciate that. Appreciate you. Appreciate the information, and especially appreciate the last minute filling in for Carolyn, so she's still on her fire assignment. Really appreciate that. So don't see anything in the chat or the question and answer, so I'll give people a minute to either for Matt or for Vaughn, here's your chance to ask some questions either about prescribed burning or smoke management. While I'm waiting to see if any questions pop up, I'm going to go ahead and drop the survey link for our seminar survey into the chat, so that you can really appreciate people to fill that out, to give us feedback on the survey. And like I said earlier, that we'll use that to develop future seminars, and hopefully maybe even next year we'll be in a spot where we can go back to doing in person and have a field and get outside element. Wouldn't that be great? So I really appreciate if you give us some feedback and some, we really look at this for ideas for topics as well. So still checking Q&A here. Don't see anything in here. Wait another little bit here, see if anybody's pops up with a question for you guys. Well, not seeing anything else pop up here in the Q&A in the chat. Yeah, thanks for Matt for putting that link for the burn locations, the WTFP stuff in there. Appreciate that. Here's a question. Any ideas on how to get neighbors interested in fire prevention? Either you guys want to take that one?
There are a lot of
Oh, go ahead, Matt.
community groups that go together, like Met Howe and other ones where they can put in, you know, community wildfire action plans, but check and see what you have for community wildfire groups out there, or check in with DNR. They've got a pretty good substantial list of groups as well that are active.
Hey, Vaughn, were you going to add something, or?
Yeah, I was just going to say the Firewise communities, getting Firewise to come out, or some Firewise representatives to come out and talk. And there's people within DNR that are that do that sort of thing. I haven't spent a lot of time with it, so I'm not the best person to ask about it, but that is something that is available.
All right, thanks, guys. I'm just doing another check here. Nothing in Q&A and nothing else in the chat. So I think we'll go ahead and wrap things up, and just once again kind of do a virtual round of applause to Matt and Vaughn. Appreciate you both for your willingness to both kind of step in in the last minute and still make it so that we could have some good representation. And we appreciate the help from our state partners for you guys to come and chat with us and share your knowledge and experience with us, and really appreciate that. So and then just one more reminder for attendees to please take that opportunity to fill out the survey. Really appreciate that. And with that, I think we'll draw this seminar to a close, and appreciate everyone's participation and for you being here this evening, and wish you a good evening, and we'll talk to you soon again. Hopefully see you again soon in another one of our seminar activities. Thanks. Good night. Have a good night.